Okay, this video is on parabolas. You've probably seen parabolas before. This time we're going to talk about parabolas and a few more things. We're going to talk about the focus, the directrix, the primary focal chord. Okay, so a few more things that you might not have seen before. So first, some definitions. A parabola is the set of all points that are equidistant from a fixed line called the directrix, and a fixed point called the focus. The focus is not on the line, which is the directrix. However, we have the axis of symmetry, and that is a line that passes through the focus and is perpendicular to the directrix. The vertex, that's a point at which the parabola makes its sharpest turn. The vertex is halfway between the directrix and the focus. That's important. It's halfway between the directrix and the focus, so it's right in the middle. The distance from a point P to the focus equals the distance from the point P to the directrix. We'll call that P prime. So if we look at our vertex on this graph, the vertex is that black dot. The focus is inside the parabola. That's a red dot. The directrix is the same distance from the vertex to the focus, but the opposite direction, and the directrix is on the outside of the parabola. So the directrix will never intersect the parabola. So the idea here is that if we take a point P that's on the parabola, whatever the distance is from the focus to that point P is the same distance from that point P to P prime on the directrix. So if it's 4 units from the focus to P, then it's 4 units from P to P prime. Okay, we don't really worry about that too much, but we are going to have to find the focus and the directrix and the vertex. A couple more things. Okay, you should always pause, write down the notes, and then come back when you're ready. Okay, so what we're going to do here is we're going to talk about a parabola where its vertex is at the origin. So that's really a special case. We're going to talk about parabolas where the vertex is not at the origin in a little bit, but right now we're just getting used to it. So we're going to talk about simple parabolas. Maybe they're not so simple, but they're less complicated if the vertex is at the origin. Okay, so here's the formula, the standard form, which is x squared equals 4py. Its vertex is at the origin, and the y-axis is its axis of symmetry, so that just means it's the same on both sides of the y-axis. 0, p is the focus. Okay, so that p comes from the formula. See how there's a 4p in front of the y? That's where we get the p from. If p is greater than 0, then the parabola opens up. And if p is less than 0, then the parabola opens down. And then the directrix, in that box, there's a little summary there. The directrix is y equals negative p. So what the deal is, whatever the distance is from the vertex to the focus, let's say it's 2 units. Then what you do is you just count the same number of units down, 2, and then that's where you would draw the directrix. So it's the same distance. Okay. If the parabola was going up, then the directrix would be above the parabola. I think I said that wrong. If the parabola was going downward, so envision a parabola that opens downward, then the directrix would be above the parabola. opposite of what this picture looks like. Okay, a few more definitions. I know it's a little long, but we got to get through these kind of definitions before we do some problems. A line segment that contains a focus and whose endpoints are on the parabola is called a focal chord. Okay, so a chord goes from one point on the parabola to another point on the parabola. That's what a chord is. A chord is a line segment. A focal chord just means it goes through the focus. But then we have a specific focal chord that's parallel to the directrix, and it's called the primary focal chord. And the only difference between that chord and a focal chord is that it's parallel to the directrix. That's what we're going to be looking for. We're going to be looking for the primary focal chord. Okay, and more specifically, we're going to look for the endpoints of the primary focal chord. Okay, the entire length of the primary focal chord is the absolute value of 4p units. Okay, so we're talking about the length of how long this line segment is. If p is 1, then it'll be 4 units long. If p is 2, it'll be 8 units long. So that's the distance from one point to the other. So this will be useful when graphing parabolas. And then I wrote the line QP is the primary focal chord. So you can see that it's parallel to the directrix. So going from Q to P. Okay, now it starts looking a little complicated. The point P is x comma P. And I didn't put the point for Q, but it's negative x comma P. Anyways, we're not going to try to memorize so many things. It gets a little bit impossible. We're just going to count. So don't panic yet. We're just going to count. Everybody can do that. Okay, so here's our procedure. To find the focus and the directrix of the parabola, x squared equals 4py, and sketch its graph. I didn't write the vertex because we know the vertex is 0, 0. Okay, step 1 is we're going to compare the standard form to x squared equals 4py to find p. If p is greater than 0, it opens up, and if it's less than 0, it opens down. Then we're going to find the directrix. The equation for the directrix is y equals negative p. And then we're going to find the endpoints of the primary focal chord. And the length is absolute value of 4p. So what we're going to do is we're going to go 2p to the right and 2p to the left. Okay. So I know I wrote 2p comma p and negative 2p comma p. It'll make sense when we're graphing. Oh, by the way, it's a good idea to get some graph paper. On my website, on bobsmathclass.com, I should have some graph paper samples to print if you wanted to. Or you could just go to Google and just type in graph paper, and you'll get all kinds of options to get some graph paper if you don't want to go to the store or order some. Just print some up at home. Okay, here we go. Focus, directrix, focal chord endpoints, and then sketch the graph. And we know what the center is, right? The center is 0, 0. We'll get into it a little bit. It's h and k, h comma k, kind of like the circles that you might have done. And in this case, there is no h and k, so that's why it's 0, 0. Okay, so there's our center, 0, 0. I put a black dot on the graph. Okay, so now we're going to compare x squared equals 8y to the standard form, x squared equals 4py to find p. So it's already in the correct form. All you're going to do is replace 8 with 4p. Okay, I don't think I said that right. Set 4p equal to 8. So the x squared is the same on both sides. The y is the same. So we're comparing 8 to 4p. That's our equation. So 4p equals 8. Divide by 4 on both sides. That gives you p equals 2. Hopefully that makes sense. So all we do is write 4p equal to 8, whatever that number is. It's always going to be 4p. Okay, we got 2. Now, 2 is a positive number. That means if it's positive, it opens up. So think about that your parabola is going to open up, and the focus is always inside. So then you're just going to count up 2 units, and then that's where your focus is going to be. So your focus is at 0, 2. So just count up to 1, 2, and then put a dot. Now our directrix. Well, the directrix is going to be the opposite direction. So you're just going to count down 2 units. So if you count down 2 units, you're going to be at -2 on the y-axis, and then draw a horizontal line. So that'll be y equals -2. So see how we just counted? We went 2 up because p was 2, so we went 2 up for the focus, and then you go down 2, so just count 2, 1, 2, down to the directrix, and then draw a horizontal line. Okay, next is the endpoints. So the whole distance through the focus is 4p. And what you're going to do is you're going to figure out what 2p is. It's going to be 2p to the right and 2p to the left. Well, p is 2, right? So it's 2 times 2, which is 4. So you're going to count 4 left and 4 right. And then that's where your endpoints are. So just count over 4 to the left, put a point, 4 to the right, and that gives you 4, 2, and -4, 2. Put those 2 points in. And then we're done. Now we could sketch it. Just draw a parabola that hits the vertex and our endpoints, and extend it going upwards. Okay, so now we're going to talk about parabolas where the vertex is not at the origin and it's opening up or down. We'll talk about parabolas in a little bit that open left or right, but we'll hold off for that for now. Okay, so here's our standard form. X minus h squared equals 4p times y minus k. Okay, so this is the standard form. This is really the form you want to memorize. The other one, I just wanted you to get used to this. Maybe it's a bad plan, but we're just trying to get used to it little by little, but this is the formula that you want to memorize. Okay, so let's plot a parabola. There's a vertex. This parabola is going up. I did put the focus as h comma k plus p. The reason is let's say p is 2. All we're going to do is we're going to add 2 to the k value of the vertex. So whatever the value of p is, you either add it or subtract it from the k value of the vertex. In this case, it's going up, so we're going to add 2. If the parabola was opening downward, then you would subtract 2. The directrix is the opposite distance outside of the parabola, so there's the picture of our directrix. And then our endpoints would be 2p to the left and 2p to the right. From our focus. Okay, so again, just getting used to where everything is. We're going to graph our vertex. We're going to count p units up or down to get our focus. The opposite distance will be the directrix. And then from the focus, we're going to go 2p to the left and 2p to the right to get our endpoints of the primary focal chord. And then sketch the graph. Maybe it's a lot, but you could do it. Okay, here's our first problem. We want the vertex, focus, directrix, and focal chord endpoints, and then sketch the graph. Okay, so this is already in standard form. Later on, we'll do problems where it's not in standard form, but right now this is in standard form. So first step is, what is our vertex? Okay, so it's h comma k. Just like circles, just think about the opposite value of the number after the minus sign. So x minus 3, so the opposite will be positive 3, and y plus 1, so the opposite will be negative 1. So our vertex is 3, negative 1. Okay, there's a graph of 3, negative 1. And then set 4p equal to 8. So if you set 4p equal to 8, that gives us p equals 2. So whatever that number is in front of the parentheses where y is on the right-hand side, you always put 4p equal to that value. That gives you p equals 2. So you divide by 4 on both sides. It's positive, so that means a parabola opens up. So we're going to count 2 units up from our vertex. So the vertex is at 3, negative 1. So if you go up 2 units, you'll be at 3, positive 1. And then we're going to go down 2 units. If we're at 3, negative 1 from the vertex, we go down 2 units. That'll put you at negative 3, and then you draw a horizontal line, so that gives you y equals negative 3. Okay, if you use the formulas, it's h equals h comma k plus p. So negative 1 plus 2, that gives you 1. And then the directrix is y equals k minus p, so y equals negative 1 minus 2, which is negative 3. I don't really like that. Just count 2. 2 up, 2 down. Draw your directrix. Okay, next is the endpoints. We're going to go a value of 2p to the left and right. P is 2, so 2 times 2 is 4. So you count 4 from the focus. So go 4 to the right and 4 to the left. That should give you negative 1, 1, and 7, 1. Alright, that looks good. That's it. Now we could draw our parabola sketched in. Okay, so just to recap, vertex was 3, comma negative 1. Set 4p equal to 8, that gives you p equals 2. So count 2 up for focus, which is always inside the parabola, and then 2 down, but draw a horizontal line. It's not a point, it's just a line. And then 2p left and right from our focus, so just count over 4 units from 3, 1, or you could add 4 to the x value, so 3 plus 4 is 7, and 3 minus 4 is negative 1. Alright, let's move on. Okay, here's another example. Find the vertex, focus, directrix, endpoints, sketch. First step is compare it to the standard form. X minus h squared equals 4p times y minus k. What's our h and what's our k? Right, the h is 4 and the k is 0 because there's nothing in parentheses there. So our vertex is 4, 0. And then set 4p equal to negative 8. So if you divide by 4 on both sides, you'll get negative 2. So 4, 0 and p equals negative 2. So now we're going to count down 2 units. Again, p equals negative 2, that should tell you about the parabola. If p is less than 0, it opens downward. Right? If p is greater than 0, it opens upward. So this parabola opens down. We're going to count 2 units from 4 to 0. So that'll give you 4, negative 2. And then we're going to count up 2 units from 4 to 0, and that'll give you the directrix. All right, so y equals positive 2 is your directrix. Okay, what's left? Endpoints, right? 2 times p. Well, p is negative 2, so 2 times negative 2 is negative 4, but we're going to take the absolute value. So you get 4. So that's 4 to the left, 4 to the right, from the focus. So if you count over 4 to the right, you should get 8, negative 2, and 4 to the left, 0, negative 2. And now we can sketch the graph. Okay, now we're going to talk about parabolas that open to the left and right. We'll do the same thing we did last time. We're going to talk about parabolas that have its vertex at the origin. So this is really just a special case of a parabola. And then we'll talk about parabolas where the vertex may not be at the origin. Okay, so here's our standard form with the vertex at the origin, and the x-axis is its axis of symmetry. The formula is y squared equals 4px, where 0, p is the focus. If p is greater than 0, so if p is positive, it opens to the right. And if p is less than 0, it opens to the left. Again, the focus is always inside the parabola. This one just opens to the sideways, to the right. The directrix is always outside. So in this case, our directrix is a vertical line. When a parabola opens up or down, the directrix is a horizontal line. But when it opens left or right, the directrix is a vertical line. Okay, let's do a problem. The procedure is just about the same. We're going to compare it to the standard form. P is greater than 0, it opens to the right. Less than 0, it opens to the left. The focus is at P0. The directrix is x equals negative P. And the endpoints are P, 2P and P, negative 2P, or 2P units up and 2P units down. So this time, instead of going 2P left and 2P right, we're going to go up and down. Again, I try not to memorize all these little formulas, P, 2P, it's too much. So again, we're going to count. Okay, find the focus, directrix, endpoints of the parabola. We know our vertex is at 0, 0. There is no h and k in this problem. By the way, h always goes with x and k always goes with y. Now we're going to compare to the standard form, which is y squared equals 4py. Okay, so we're going to compare 4p to 12. Well, if you compare 4p to 12, what is p? Yeah, p equals 3. So now we're going to count 3 units to the right. Since it's 3 units to the right, it opens to the right. The focus is at 3, 0. When we got a positive value, that told us that the parabola opens to the right. If we would have got a negative value, that would mean the parabola opens to the left. The focus is always inside of the parabola. Okay, now the directrix, we just count 3 units the opposite direction. So if you count 3 units, that's going to give you x equals -3. All right, next, focal chord endpoints. We do 2 times p, and that's going to go up and down from the focus. So 2 times p is 3, so 2 times 3 is 6. So you're just going to count 6 up and 6 down. 6 up, 6 down from the focus. And that should give you 3, 6, and 3, -6. Now we have all our information. Draw in your parabola, and we're all done. Okay, so now we're going to talk about the formula for a parabola that opens left or right when the vertex is not at the origin. It's y minus k squared equals 4p times x minus h. The vertex is always h comma k. Notice that the h is on the side with the x value, or the variable x, and k is on the left side with the variable y. Okay, so let's just say here's our vertex, h comma k, and our value of p is positive, so we're going to go to the right. The directrix is going to be on the opposite side. The parabola always goes along the axis of symmetry. The focal chord endpoints are 2p up and down from the focus. And then we can sketch our graph. Okay, so vertex, focus, endpoints, directrix. Those are the 4 things we're going to need to find. Let's do it. Okay, find the vertex, focus, directrix, focal chord endpoints of the given parabola and sketch its graph. First thing we need to do is start with the vertex. What is our vertex? It's hk. Remember, h is with the x and k is with the y. So in this case, our hk is -1, 3. Right? The x goes first, y goes second. And then our value of p, well, we always set 4p equal to the number in front of the parentheses on the right-hand side. So 4p equals 8. Therefore, p equals 2. Okay, so let's start with our vertex. Plot the vertex, which is at -1, 3. Okay, now it's a y squared. Our standard form, the variable of y is the one that's squared. If we expanded it, it would be y squared minus 6y plus 9. So that's why I said the y is squared. So since our y is squared, it opens left or right. If the x is squared, it opens up or down. So this one opens left or right. The value of p equals 2, since it's positive, that means it's going to open to the right. So just count 2 units to the right, and that will be where the focus is. So that will be 1, 3. All right, so 2 units from the vertex, that gives you your focus. Now we're going to just count 2 units the opposite direction, so 2 units to the left, and then from that point we're going to draw a vertical line, which is the directrix. Make sure you draw it dashed. So that'll be at x equals -3. Okay, almost there. Now we need to do the endpoints, the focal chord endpoints, primary focal chord, I should say. It's 2 times p, which is 4, because p is 2. So 2 times 2, which is 4. So we're going to go 4 up and 4 down. 4 units above and below the focus. So that'll give us the points positive 1, 7, and positive 1, negative 1. And now we could sketch our parabola. So in the previous examples, the parabola was given to us in standard form. Well, what if it's not in standard form? Yeah, you're right. We have to put it in standard form. So let's make some observations here. The right-hand side is factored so that the leading coefficient of the variable is 1. So notice on the right-hand side that there's a 4p in front, but inside the variable is just a 1. Sorry, the coefficient of the variable is a 1. It's a 1y or a 1x. Okay. On the left-hand side, the variable is squared. Okay, so let's read number 1. Write the variable which is squared along with any terms with the same variable on the left-hand side. So this is very similar to the circles video that we just did. We're going to do some completing the square. So you're going to put the variable that's squared on the left. If it's x squared, put it on the left. If it's y squared, put it on the left. And then put any other of the same variable terms on the left along with it. Okay. Number 2, write the variable which is not squared along with the constant on the right-hand side. So the variable that's not squared goes on the right-hand side along with a constant if we have one. And then number 3, we're going to use completing the square of the left-hand side to create a binomial squared. And then we're going to factor out the coefficient of the variable on the right-hand side. And don't forget, when you complete the square, whatever number you add on the left side, you have to add the same number to the right side. Okay, it seems like a lot. Main thing is get the squared terms on one side, and its variable, and the variable that's not squared, put it on the right side. Okay, here's our first example. We're not going to graph it, we're just going to write it in standard form. So which is the variable that's squared? Right, the x. So that's going to stay on the left-hand side. The variable that's not squared, which in this case is the y, you're going to move that to the right-hand side along with any constant, which is the 16. Okay, so write the variable which is squared along with any terms with the same variable on the left-hand side, and write the variable which is not squared along with the constant on the right-hand side. Okay, so that gives us x squared equals negative 8y minus 16. Now there's no other x term, so we're not going to have to do any completing the square. We're just going to look at the right side, and we want to factor out the number that's in front of the y. So in this case, it's a negative 8. So you always want the coefficient of the y inside the parentheses to be a 1. So factor out a negative 8 on the right-hand side, and we're all done. X squared equals negative 8 times y plus 2. It is now in standard form. Our center is 0, negative 2, and then we could set the 4p equal to negative 8 to get our value of p, which is negative 2, etc. We can go through the whole process of graphing that parabola now that it's in standard form. Okay, we'll do that in a little bit. Let's practice this some more. Okay, here's the next one. Which is the variable that's squared? The x. That's going to stay on the left-hand side. The variable that's not squared is going to go on the right-hand side, along with any constant. The constant here is a negative 8. So again, here's some notes. Write the variable which is squared along with any term with the same variable on the left-hand side and the variable that's not squared on the right-hand side. So there we go. We have x squared plus 8x equals 12y plus 8. Okay, now we're going to complete the square. Do you remember the process? We take half of the x term in this case. So we're going to take half of 8, which is 4, and then we're going to square it, which is 16. Okay, so there's a note on the left-hand side. We're going to use completing the square to create a binomial squared. Multiply the middle term by 1/2 and then square it. Add that number to both sides. So 16. Add 16 on the left and 16 on the right. Okay, now we're going to write the left-hand side as a binomial square. Or in other words, we're going to factor it, and it's the same factor twice, so that's why it's going to be squared. This is called a perfect square trinomial. A perfect square trinomial always factors to a binomial squared. So that's going to be x plus 4 squared. It's always going to be half of the middle number. 4 times 4 is 16, and 4 plus 4 is 8. Now on the right-hand side, we have to factor out the number that's in front of the y. So that'll be 12. Factor out a 12. And we're all done. X plus 4 squared equals 12 times y plus 2. The vertex, what would the vertex be? Right, it'll be -4, -2. What's the value of p? P is +3. So which way does this parabola open? Right, it opens up. Anytime it's an x squared, it opens up or down. If the y is squared, it opens left or right. If it opens up or down, if p is positive, it opens up. If p is negative, it opens down. If it's a y squared and it opens left and right, sorry, left or right. If p is positive, it opens to the right. If p is negative, it opens to the left. Okay, that was a lot of information there. Okay, let's find the vertex, the focus, the directrix, the focal chord endpoints of the given parabola, and then we're going to sketch the graph. So the variable that's squared, that's going to stay on the left-hand side. The variable that's not squared, you're going to move that over to the right-hand side. The constant is going to go also on the right-hand side, along with the variable that's not squared. Okay, so which one stays on the left? The y's, right? Y squared. Okay, so the y squared minus 4y stays on the left-hand side. The 8x and 20 move over to the right-hand side. Remember, when you move a term from one side to the other, the sign will change. Okay, so now we're going to complete the square. We're going to take half of -4. What's half of -4? That's -2, and then we're going to square it. So what number are you going to add to both sides? Right, 4. So we're adding 4 on the left and the right. Okay, now on the left-hand side, we're just going to write it as a binomial square, or in other words, factor it. It comes out to the same binomial, so it's y minus 2 times another y minus 2, or y minus 2 squared. And on the right-hand side, just add the 20 and the 4. Okay, so the 20 and the 4, that gives us a 24. So on the left-hand side, that'll give you y minus 2 squared. And on the right side, factor out the 8. So there we have it. We have the parabola in standard form. Since the y is the variable that's squared, that means this parabola will either open to the left or the right. When the parabola has the variable x that's squared, it either opens up or down. Okay, so let's find the vertex. What is our vertex? Our vertex is -3, +2. It's always the x and then the y, or the h and then k, h comma k. So -3, 2. Okay, now let's find the focus. So the focus, we set 4p equal to the number in front of the parentheses on the right hand side. So 4p equals 8 divided by 4, that gives us p equals 2. It's a positive value. We've already established that this parabola either opens left or right. Since p is positive, it will therefore open to the right. If p was negative, it would then open to the left. Okay, so we have our vertex, which is at -3, 2, and all we're going to do is count. Count 2 units to the right, and then that will be where the focus is. So we can either use the formulas, h plus p, comma k, or just count. So it gives us -1, 2. Now the directrix, again, count 2 units the opposite direction, or you could use x equals h minus p, which is -5. Okay, so I've said it before, I'm not really a fan of all the formulas. I like to just count. So 2 to the right for the focus, 2 to the left for the directrix. Okay, what's next? Endpoints, right? So the endpoints, we use that formula 2 times p. So 2 times 2 is 4. So we're going to count 4 up and 4 down from the focus. That should give you -1, -2, and -1, 6. And now we could draw our parabola. Okay. Okay, we're going to move on now to almost a new topic. This time, we're going to find the equation of the parabola. And I want to use the facts of what we know, that the vertex is right in the middle between the focus and the directrix. Actually, a point on the directrix that goes through the axis of symmetry. Okay, so it says here, keep in mind that the vertex is the midpoint of the focus and the closest point on the directrix. Midpoint, okay? Those two distances are the same when we say the midpoint, because the vertex is right in the middle. Although we're not required to graph the parabola, it's definitely a good idea to make a rough sketch using the information given and your knowledge of parabolas. So I'm saying to make a sketch just so we could think about which way does this parabola open. Does it open to the left and right, or left or right? If it opens to the left or right, that tells us which standard form to use. If it opens up or down, it's a different standard formula. If the parabola is going up or to the right, then p has to be positive. If it's opening to the left or down, then p has to be negative. Okay, here we go. We're going to find the equation. Now, it doesn't say to sketch, but we're going to make a little sketch anyways. The focus is 0, 2, and the directrix is y equals -2. Okay, so here's our focus, 0, 2, just a rough sketch. And the directrix is at y equals -2. So what does that tell us about the parabola? Which way will it open? It has to open up, right? The parabola will never intersect with the directrix, and the focus is always inside the parabola. So this parabola opens up. That means we're going to use the standard form that has the x that's squared. Okay. The vertex is right in the middle between those 2 points. It's right in the middle between 0, 2, and the value of the point that's on the directrix, y equals -2. So between 2 and -2, the midpoint has to be 0. So our vertex is 0, 0. Right in the middle. Okay, that means our parabola opens up because the focus is always inside the parabola. So we need to find what P is. If it opens up, P is positive. If the parabola were open downward, not in this case, but if it did, P would be negative. So in this case, the value of P is 2. So that's important. So we're going to need to know the value of P and which formula we're going to need to use. Which way does a parabola open? That will tell us which formula. So in this case, we're going to use the formula x minus h squared equals 4p times y minus k. Okay, so I should have said 2 things. We're going to need the vertex, which in this case we have, it's 0, 0. The value of p, which is 2, and then we're going to insert those values into our formula. Because it opens up, we're using the formula that's at x squared. If it were open to the left or right, we would use the formula that has the y that's squared. Okay, so I just put the answer here, put in 0 for the h, 0 for the k, and 2 for your p. Y minus 0 on the right is just y, x minus 0 is just x, so it's x squared equals 8y. X squared equals 8y, that usually is fine. Sometimes they want the 0 on the right hand side, so you might have to move the 0 over to, you might have to move the 8y over to the left side. Either one is usually fine. X squared equals 8y, or x squared minus 8y equals 0. Okay, example 10. Find the equation. The focus is at 5, -2, and y equals 6. So let's plot those two guys. There's y equals 6, and there's 5, -2, which is the focus. The vertex has to be somewhere in the middle, right? Exactly in the middle. So it's kind of like the midpoint. You could start counting, like get to the middle from 6 on the y and -2 on the y. The easiest way to do it is to add those two values, the two y values. So 6 plus -2 is 4, and then divide it by 2, which is 2. Okay, so that's the y value of the vertex, and the x value of the vertex will be the same value as the x value of the focus, because the focus and the vertex are along the axis of symmetry. Okay, so it's got to be right above the focus. This parabola opens downward because the focus is inside. So you want to find the midpoint between 6 and -2. The total distance from 6 to -2 is 8 units. So half of 8 units is 4 units. You can either count up 4 units from the focus, or down 4 units from the directrix, or you can use the midpoint formula The midpoint formula is you add the two values and then divide by 2. That's why I said 6 plus negative 2 is 4, and then divided by 2, which is 2. Okay, so I hope that made sense on how we're finding our vertex. Our vertex, therefore, is 5, 2. Okay, so again, it's right in the middle between the directrix and the focus. The total distance between the directrix and the focus was 8 units. Half of 8 is 4. So count up 4 from the focus or down 4 from the directrix. That's usually the easiest way. Okay, so now we have our vertex. Now what is the value of P? P is the distance from the vertex to the focus. So how many units is that? Yeah, it's 4. So P is 4, and is it going to be positive or negative? Since this parabola goes down, P should be negative. So P equals negative 4. Okay, so a little sketch. The parabola goes down. The vertex is right in the middle between the focus and the directrix. Because this parabola goes either up or down, we're going to use the formula that's an x squared. So here's our formula, x minus h squared equals 4p times y minus k. The h is 5, the k is 2, the value of p is negative 4. So insert those values into the formula, simplify it, and we're all done. Usually at this point it's okay, depends on your teacher, so make sure you always check what form they want the parabola in. I kind of like this form right here, x minus 5 squared equals negative 16 times y minus 2. Some textbooks or teachers want you to get a 0 on the right hand side, so you might have to square the left hand side, distribute the negative 16. That's really just a lot of busy work. And then you should get this result. X squared minus 10x plus 16y minus 7 equals 0. But again, it depends on the teacher. The row above probably would suffice. Okay, I know it's a long video. We're almost there. Couple more problems. Here's our focus, 8, 0. Our directrix is at x equals negative 2. Let's plot those, graph the directrix, and let's decide which way this parabola opens. Okay, so there's our directrix. It's vertical. Our focus is 8, 0. So that means it has to open to the right, right? The focus is always inside. It doesn't intersect the directrix, so it opens to the right. And we need to find the midpoint between negative 2 and 8. Let's see, what's the distance from negative 2 to 8? It's 10 units, right? So half of 10 is 5. So you could either count back 5 from the focus, or go up 5, count to the right 5 from the directrix. So that should give us the point 3, 0. That's our vertex. Okay, so the parabola then opens to the right. We need the value of P. The distance from the vertex to the focus is 5 units. Since it opens to the right, then the value of P should be positive. So P equals 5. We have our information. We have our H, we have our K, we have our P. It opens to the right, so make sure you use the correct formula. Use the formula with the y that's squared. Insert everything into the formula. Y minus 0 is just y. 4 times 5 is 20. Again, I kind of like that form right there. Y squared equals 20 times x minus 3. You may have to get a 0 on the right, so distribute the 20 and then bring everything to the left-hand side. That'll give you y squared minus 20x plus 60 equals 0. Again, it depends on your teacher. All right, one more problem. Hang in there. Focus is at negative 4 comma 5, and the directrix is at x equals 2. Okay, so there's our focus, negative 4 comma 5. Our directrix is x equals 2. Which way does this parabola open? It has to open to the left, right? It has to open to the left. So we're going to use the formula with the y that's squared. If it opens left or right, use the y squared formula. If it opens up or down, use the x squared formula. Okay, so let's find the vertex. So we're looking at the x values. Sometimes people get confused, like, what do I use here to find the vertex? You see the directrix? It's an x value, right? So that means you're going to use the two x values. If the directrix was a y equals, then you're going to use the two y values to find the midpoint. Okay, so we're going to use the two x values. We're trying to find the distance from negative 4 to 2. So from negative 4 to 2 is how many units? That's right, 6. Right? 6 units. Negative 4 to 0 would be 4, and then another 2 units, that would be 6. So what's half of 6? 3. So we're going to count 3 units to the right from the focus, or 3 units to the left from the directrix. So there it is. There's our vertex. Negative 1 comma 5. That's our vertex, and we know it opens to the left. So therefore, we need to find the value of P. How far is it from the vertex to the focus? It's 3 units. Is it going to be a positive 3 or a negative 3? Since it opens to the left, it's going to be a negative 3. So the value of P is negative 3. And then we're using the y squared formula. We have our information. We have our h and k, which is the vertex, and we have our P, which is negative 3. Plug it in. Simplify. Okay, right here at this point, y minus 5 squared equals negative 12 times x plus 1. That's usually a good spot. If you have to, write the y minus 5 twice, FOIL, distribute the negative 12, get all terms on one side, and then you should end up with this, y squared minus 10y plus 12x plus 37 equals 0. Okay, that's it. I know it's a long video. It's almost an hour. Yeah, you did a good job by hanging in there. I'll see you here for the next video. Bye.